Hey there YouTube, Superbrain AK here, and check it out. I have changed around my DC to DC converter. I am now using the homemade transformer that I made a while back to give me high current on the output. It was originally for my ZVS driver, which I'll briefly talk about. He's sitting right here, and its output is connected on the capacitor bank to an ATX transformer. I actually split the ground wires out, but anyway, he's sitting there, and this powering the original primary of Mr. Beefy there, the flyback. He pulls 12 amps at 5 volts because it kicks into current limit of my DPS 3012 and it drops the voltage down to 5 volts. So that doesn't give me much output. So that's why I configure this guy to give me really high current. There are 3 14 gauge wires in parallel, and there's 3 turns on it. And I did have to reduce the primary of this because it was way too much, which is kind of what I'm running into issues with. A high voltage on the input, I'm putting 30 volts in, and the MOSFET isn't turning on quick enough. So because, you know, this is the gate wire going down to the driver. So, yeah. Anyway. But anyway, I have 2 14 gauge wires coming up. I have both of these diodes now. Both of these double diodes in parallel. So they're rectifying the output, and then on equally matched wires, because this one is shorter, so this one is longer, and this is short, so this one's longer. So they're all the same length, if you can imagine that. And then it's going down to, if you can see it past the oscilloscope probes, a capacitor bank. It's got 2 ceramic capacitors and 4 electrolytics. If you can see that there. But yeah, that's 3.9 millifarads or 3,900 microfarads of capacitance, and those are all under, 0.8 to 0.4 milliohms, and then the ceramic capacitors are basically 0. So, and I did change this, so the input voltage can vary from 5 to 30 volts, but this is a SEPIC converter, which is actually the same module type as the main driver board, but this one I'm only using for the 6009. But this is regulating the input voltage, see the black and yellow coming from there, down to 12, which goes on this side, which goes to the driver and the logic. Yep. And you might be able to see I added extra logic. So this Zener here, you can see that resistor, this is the main input, this is the regulated 12 volt. So the main input goes through this Zener, which turns on this transistor, which then drives this PNP transistor, which pulls up the base of this PNP transistor, which is normally pulled low when everything first turns on. And that is sending through this resistor voltage to the feedback So when the voltage is too low, under like 14 volts, it tricks it into thinking, hey, we've got good grid voltage. And that's what that LED is to indicate. And then this LED is indicating if the optocoupler is turned on or not. And this is the feedback area coming from the output of the really low ESR capacitor bank, which I believe I need to work on the input side and get rid of these really long wires everywhere. So that's the plan, is to rebuild it, put this all on circuit board, soldered up, put the board right under the MOSFET, and then worry about this at a later date. See if just changing this to an actual circuit board will be an improvement. So unfortunately I don't have the meters connected here. I'm just using the meters on my 50/30/12 and DC load. So I'm going to turn it on and listen for the click. I also have the scope connected on the input and the output. So this is measuring the voltage. And you'll hear it turn on right now. Boing. It's on. 12 volts on the output. Let's see if we can kick out 3.6 amps. There we go. Also, you may have spotted that green LED there. That is the actual pulse of the gate drive. So that the gate is triggering that LED as well as the MOSFET. So we're getting about 68 watts input and 44.5 on the output. So fortunately that does not make it very efficient. And the oscilloscope, if you can see all those scalings there, but there's certainly some noise there on the ground. So I'm going to have to calculate those different things. But yeah, the main MOSFET is toasty. Turn it off. Bonk. Ouch. Yeah, MOSFET's not being driven very well. I've got some other scope data to prove that, so I'll have to put it all together. But anyway, let's calculate that efficiency. What is it, 39 in, 40 out? Let's test it. 44.5 over 68.7. So we are only running at 65% efficiency, which is not very good. The best I've ever gotten is 70%. And that was running with the extra inductance on the primary. And not even at 30 volts, was at 24. So I think the next video you see with this in it will be soldered onto a breadboard, which is going to take some time. So I'll show you a glimpse of another project that's in the works. Look at all them MOSFETs. So there's 2 IRFP 260s, and then 4 of these double diodes, which are B20100Gs. And those are in parallel. And those are going to be hooked up to these boost converter modules. So I'm going to put a plate of metal here, and it looks all pretty. Anyway, I'm going to stop waffling, and I will see you in the next video. Cheers.